9.4 question 2. Draw a pair of axes, already done, from -5 to 5. I've gone from -6 to 6, never mind. Draw the quadrilateral, which we're going to call M, by plotting the following points and joining the vertices. So -3, 2. -3, 2 is there. -3, -1. So it's -3, -1 there. -2, -1. Just about fits there. And -1, 2. So it looks like I've got a bit of a trapezium thing going on here. In fact, let's just call it trapezium, that's what it is. Join the vertices to get the trapezium we're looking for. Perhaps I should have paused the video to do this bit so you don't get too bored with watching me trying to work this pen facility. Okay, that's alright. Draw the reflection of M. Oh, by the way, this is now called shape M, so let's call it that. Reflect M in the line y equals -1 and label the image M dashed. Please note that's M dashed. So let me first of all draw the line y equals -1. So okay, y equals -2, that's y equals -4, y equals -3. So this right across there is the line y equals -1, and I'll label it as such because it's true. And it's a very, very easy reflection, so I won't pause the video, I'll just jump straight in and do it. So right, so these are sitting on the line, they're sitting on the mirror. When you reflect them, they stay put. Let's just count here. 2 units. Oh, is it 3? Yeah, 3 units above the line. 1, 2, 3 units below. Then we're going to go 1, 2 units across. 1, 2. And now we're just going to join the vertices. Use a different colour, I think. Be nice. Let's go for an orangey one, it's quite pleasant. Go back to the orange and call it up, come on. Right, there it is. So join that to that, join that to that, and that to that. And I won't put the orange on top of there you go, I've overwritten the blue line and the red line from shape M. So now I've got to label this M dashed, it's the image of M after a reflection of the line y equals -1. Now I've got to rotate this. I'll probably just pause it and contemplate. Remember, I'm not playing with tracing paper. I have to do it rough first and think about it, and I'll get back to you. So we'll pause and we just get back. Okay, that's a very straightforward rotation as it goes. There's the centre of rotation. I'll label it as such. Centre of rotation. And that was, according to the question, 0, -1. So 0, -1 down. As you can see, that's gone way over there, so we can just imagine going like that, and this coming back round, I suppose. So that's a rotation there of 180 degrees. So, and then it says describe fully the single transformation that maps M, the original M, onto the image M dash dash, which is that second image. Alright, so very, very straightforward. I won't draw here, but look, as you can see, they're like facing each other. So I think M can be reflected in the y-axis onto M dash dash. So I'm now going to write that in blue up here somewhere. Reflect M in the y-axis. Now what is better still is to name the equation of the line, which is the line x equals 0. Remember, all the x lines go vertical, so x equals -6 is that one, x equals 4 is that one, and so x equals 0 passes to the point 0, 0. So reflect M in the y-axis, or better still in the line with equation x equals 0, and that's it. You will get onto M dash dash. Alright, that's question 2 done. I think there's time in this short video just to carry on with question 3. Yeah, we'll do it, and I may even need to just pause a little bit, see how it goes. Copy the diagram. Yes, I've done it. Got it on the screen right here. It says draw the image of T, this is triangle T, after a vector translation of -4, -9, and we're going to label it U. -4, -9, so essentially I'm going 4 that way and I'm coming 9 down, so it's -4 to the left, -9 coming down. So let's just take this as a leading point. So -4, let's count with me. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that is where that part, not really well, let's just rub this out and do it clearer. So that's right there. Just check again, it's getting a bit glitchy. 1, 2, 3, 4. Then come down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's good. If I'm going to translate, then all these 3 vertices come with me. So I've got 1, 2, 3, 4, 5. So the triangle is essentially 5 units tall. 1, 2, 3, 4, 5. Plonk it right there. It goes 3 units across. So I'm just going to count 3 with this facility here. Not perfectly accurate. And then just join the 2 vertices like so. Alright, so this is the new image, and this new image is called triangle U. Alright, so that's U done. It then says reflect U in the line x equals 2. So let's get this facility going now. X equals 2 is this wonderful line here. A bit wonky, but forgive me, I'm doing the best job I can. So that's x equals 2. It's miles away. Anyway, we've got to count really carefully. So let's just count from here. 1, 2, 3, 4, 5, 6, 7, 8 units to the mirror. Now we're going to go 8 units that way. 1, 2, 3, 4, 5, 6, 7, 8. I'm glad that fits. Well, if that's the reflection of that point just there, then I'm allowed to go 5 units straight down to match the length of this triangle U, or the height of this triangle U. Use my straight line facility for this. So 5 units, 1, 2, 3, 4, 5, and then if this is going 3 units into the line, this will also go 3 units into the line, and then we just join the ends in the normal way, and that is the image of U after it's been reflected in the line x equals 2, and that's called new triangle V. And let's just label it then. So that's triangle V, and let's see how complicated this can be. I might just pause it and get back to you. Yes, it's quite tricky. I've got to reflect this V triangle in the line y equals minus 4.5 and label it W. Okay, new line it is then. So if we go for that facility, let's just go for a different colour line so it stands out. Green is usually quite pleasant. Right, 4.5, very, very difficult to draw. So I'm going to try and drag it across the page there and off the paper. Let's put it about there. See, I'm quite happy with that. I've now got to reflect this beautiful thing in this. Very, very difficult indeed. I think I've got it right. Reflect it in line y equals minus 4.5. Alright, well, wish me luck. I'm going to plot these 1 point at a time. It's quite difficult, I think. So this is 1.5 units below the line, so it'll end up as 1.5 units above the line. So that's the corresponding point to that one there. This is, let's have a look, 1, 2, 3.5. Let's go 3.5 below. 1, so half, 1.5, 2.5, 3.5. Just about fits on the page. So that's that one right there. And it just remains for us to do this one. Well, it's not difficult, is it? Because that's going to be directly there. And let me just join this with, don't need that. Let's just join it in black then. So that's that. This comes straight down and it overwrites the red, unfortunately, but that's the nature of such reflections that pass through the mirror line. As you can see, it looks like I've cut it right in half, as if it was like a starry type shape or half a star. Anyway, I hope you can see that in fact the red triangle V and the black upside down triangle, which I'm now called W, are in fact reflections of each other in the line y equals so of course W really doesn't really fit. I don't want it to cross into the red zone because that's triangle V. I'm going to label the line here on the side y equals minus 4.5 or minus 4.5. Hopefully that shows and I'm not in the way here where I'm just scribbling. Alright, right, now have a little pause for reflection again. This is going to get rather tricky. Having played with bits of paper and tracing paper and what have you, I think I'm going to go for, this thing will come on, I think I'm going to go for a point there as a centre of rotation. If you can imagine this whizzing round here and landing upside down on the other side in the 4th quadrant, quadrant 1, 2, 3, 4, then we have a 180 degree rotation about centre 4, 0. Again, I can't really test it on the screen. You're going to have to sort of try it out yourselves, draw it out, you know, the long way, since you're doing this in class anyway. Draw it out, ask for tracing paper. It clearly looks like a reflection. There it is, sticking up, and here it is on this side sticking down. Here this is going across towards the centre of rotation. Here it goes towards the centre of rotation in the other direction. I think it's about right, actually. I believe that. So that's it. Describe fully the single transformation that maps T onto W. So I want to go from T to W, spin it round all the way around here, clockwise or anti-clockwise, makes no difference. But the centre of rotation has to be 4, 0, otherwise it won't land. And I'll stop the video just there because I think we've done enough for about 5, 6, 7 minutes or so.